In this question, it is given that the figure shows a spherical hollow inside a solid sphere of radius r. The surface of hollow passes through the center of sphere and it touches the right side of sphere. Masses of spheres before hollowing was m. With what gravitational force does the hollow out lead sphere attach a small sphere of mass m that lies at a distance d from the center of lead sphere on a straight line connecting the centers of spheres and the hollow? So over here basically it is given that there is a solid sphere and we removed some part from the solid sphere. So we were having a solid sphere and we removed some part. So we can say that now let's say I'm just shading the remaining portion by using a red color. So this red color portion is remaining and the other part which I'm shading with the blue color portion is removed. So our aim is to find out what about the value of gravitational force only due to this red shaded portion. But we know that we don't have any such an equation to directly find out the relation for a shaded portion and the mass of this object. So what we'll do is we can just consider that it's like a solid sphere. So if it is the entire solid sphere, then if you are considering a solid sphere something like this without removing any part from it, and in question it's given that its mass is m, so we can assume that its total mass is concentrated at the center and consider that there is a particle of mass m over here which is at a distance d from the center of this solid sphere. So what we can calculate is we can find out what about the value of force exerted by the entire sphere on mass m, that we know that it is going to be g into m divided by distance is nothing but d, so we can write this as d square. But our aim is to find out what about the value of force due to the red color part. So we can write the force due to the net sphere is going to be force due to red color portion plus force due to blue color portion. And if our aim is to find out the value of force only due to red color portion, so we can write that is force due to net minus force due to blue color portion. So force due to net the entire sphere we already calculated. Now let's see what about the value of force only due to this blue color portion. So if you are calculating the force only due to this blue color portion, we can assume that the total mass is concentrated at this center of this part, and the radius of this portion is given as half of the radius, so this can be taken as r by 2. So distance from here to here can be written as d minus r divided by 2, and we don't know what about the value of mass of this, but in question it is given that its radius is 1 by 2 or r by 2. So let's see what about the value of mass of this portion over here. Now how we'll calculate the value of mass? We can write mass is equal to density into volume, as density is mass by volume. So the mass of portion that we removed, let's say it is represented by m dash, and density of the entire sphere from where this is removed is density, we can take it as mass by volume. Volume is 4 by 3 pi r cube into the volume of that part that we removed is nothing but 4 by 3 pi into r by 2, the radius of part that we removed is r by 2 whole cube. So we can write this is going to be this 4 by 3 pi r cube and this 4 by 3 pi r cube is going to get cancelled. So this is m divided by the square of 2 is going to cube of 2 is going to be 8. So we can write mass is m by 8. So the mass of the portion that we removed is nothing but m divided by 8. So we can find out what about the value of force due to that blue color part. So as we discussed, force due to the net force is going to be nothing but g into m divided by d square minus force due to that blue color portion, that is g into the mass of that portion was m divided by 8, and the mass of other particle is small letter m divided by distance between the center of portion of mass that we removed and the mass small letter m is d minus r divided by 2. So we can write this as d minus r divided by 2 the whole square. Now we can find out what about the value of net force. if I am taking this gmm divided by d square as common, so the remaining thing is 1 minus 1 divided by, we already taken gmm as common and d square is also common, so remaining thing is 8. And from here, if I am taking this d outside, it is going to be 1 minus r divided by 2d the whole square. So this will be the answer for this question.